All right. Hello, everyone. Yeah, today's workshop is going to be on Wireshark and networking as well. So, yeah, I guess we can just jump right in. So, what we're going over today is basics of networking, and it's just going to be an introduction. If you've studied networking before, a lot of this will probably be review. If not, should be a good introduction. And then after that, we'll move into an introduction of Wireshark, as well as an overview of some common networking protocols at the same time. Okay, so basics of networking. So what is networking? How do we do it? Well, the first thing you're going to want to do is make a LinkedIn profile. And after that, I have no clue. But I can teach you about computer networks. So what is a computer network? So the definition: group of computing devices called hosts connected together to allow sharing of information. So basically you have some devices, maybe your computer, your phone, your car, whatever it is, and somehow they're connected together so you can share information between those devices. That's the basic idea. And how that information is sent, we're going to use something called a packet. So basically a packet is just a unit of data that's sent over a computer network, and it's going to be formatted in some manner that it's not necessarily fixed. It'll be determined by whatever network protocol you're using, and that brings us to what is a protocol? Well, it's a set of rules for how data is formatted and transmitted. So basically, if we want to send data, we can't just send whatever. The computer is not going to know what it is. We need some sort of structure for how are we going to put that data together, how are we going to send it so we can actually interpret it and use it. So when we're talking about networks, there are a couple of models that we generally use to describe them, and they describe networks as a number of layers. So the first one is OSI, or Open Systems Interconnection Model. That one's kind of more theoretical. We'll see it right away here. And then the second one we'll look at is the TCP/IP model. So basically, the general view of how these models are going to work is there are going to be some layers, and the top layers are going to be fairly abstract. Like that might be what you interact with when you're using a computer. And as we go down, they'll become less abstract and they'll add more details. So we call this process encapsulation. So basically, when the lower protocols will take the data from a higher protocol, and they'll place that information into a packet which has some more information about how this data is going to be transmitted or whatever. And then the next layer lower than that will take that layer's data and it'll put it inside another packet. And that's kind of how these network models work. So now we'll actually look at the two models I mentioned. So the first one, the OSI model, it's going to describe networks as 7 layers. So the top layer is the end application you interact with. So for a bit of an example, I guess the OSI is a bit more of a theoretical model, and we'll be able to see a bit more of a concrete example when you look at TCP/IP, but still to give you the idea. Like if you want to look at a web page, so the browser you interact with, the browser you're interacting with it, that's going to be the application layer. Then you have next layer is a presentation layer. It deals with formatting of data, encryption, maybe some data is encoded in ASCII or something. Session layer, so it controls connections and sessions. Basically just that, establishing a session with a server that you're going to talk to. Transport layer is going to control the transmission of packets. So it's going to break down that data and decide how are we going to transport it. Network layer deals with routing, and it's kind of an interface between the higher layers that are working with the data and then the lower layers that are going to be more how we actually physically send it. And it also deals with routing, so you might use something like IP for this. We have a data link layer, which deals with transmission of data and sort of lower level error correction, flow control. The physical layer is the actual medium that you're transmitting data over. So, for example, maybe it's a copper wire or radio waves or something. And if all of that seems like kind of abstract, we'll look at the TCP/IP model. Hopefully it'll help clarify that. This one's a bit more theoretical. So TCP/IP model, well, it's named after two protocols, and this is what a lot of stuff on the internet is going to use. And it's sort of similar to the model we just looked at, but there are only 4 layers, and they kind of combine some of the ones in the previous model. So again, we're going to have an application layer as the top layer. So it's the application that you interact with in the data. So an example of this, if you're browsing a web page, the protocol that you're going to be using is probably HTTP. So that describes like how we're going to request data and how it's going to be given back to us. That's kind of like the high level view of the data we're actually working with. Then the next layer is going to be the transport layer, and same thing as the OSI model, dealing with transmission of data. And in this model, we're going to be using TCP, for example. So that's going to break down that data and determine how we can split it up and send it. Then the next layer is the internet layer, which deals with routing again. And an example of that you might commonly use is IP, and that's going to take your data and it's going to use the IP address of where you want to send it to determine where it's going to go. And then finally, we have the lowest level, the network layer. That deals with the physical transmission of data. So maybe after we've taken our data for HTTP, the request for our web page that we want to see, we've broken that down, we've determined how we're going to route it, then we're going to send it over maybe an Ethernet cable part of the way, probably not all the way. Well, I guess it depends where you're requesting, but yeah, so that's sort of a view of how this model will work. So yeah, it's a quick overview of networking. So now we'll get into using Wireshark and also some common protocols for networking. So what is Wireshark? Well, it's a network protocol analyzer. So basically, it's going to let us capture the traffic on maybe your computer or wherever, and we can save that and analyze it. It'll give us a bunch of information we can view. We can look at it. So we'll just jump into, I guess you can start using Wireshark, and you can mess around with it a bit if you want. So yeah, you can just start capturing packets on your computer. All you have to do is open it up and select the icon, or you can open up a packet capture PCAP file, format Wireshark used to store network traffic. And yeah, there's some more we can do with this. We can watch traffic on different interfaces or use certain filters. So we'll just take a look at it here. So you can see down here, I can choose like the interface I'm listening on, or maybe if I want to filter out data from a certain port, I can enter. If I want to look at HTTP data, I can enter port 80, and that would filter out only that type of data when I'm capturing the data on my computer. Yeah, just give an example. And I guess it's probably filtering it because I collect a bunch of stuff. So let's just capture everything. See, obviously we have a bunch of UDP packets here. That's probably because I'm streaming right now. Yeah, that's. So now, once we've actually captured data, what do we have here? What are we looking at? So the top part is going to be the packet list pane. So that shows all the packets that we've captured going over our network. And it displays a bunch of different details about them. For example, the time since you started capturing, the IP address, where it's coming from and going to. Seeing they're saying this stream is not showing up well. I don't know what I can do about that. Yeah, sorry guys, I don't know how I can make that any more clear, really. Okay, is that better?
That's much better.
Okay, okay,
that's incredibly clear now.
All right. Okay, so yeah, so what Wireshark show us the packet list? So we have source to destination IP, and then it'll tell us the protocol that's being used, and generally here it's going to show us the highest level protocol that's being used, and then there'll be some other information there like a packet number, the length of the packet, and then some other information that's going to depend on what protocol we're using. So then second part, when we're looking at stuff, is the packet details pane, and that's just going to show us detailed information about the packet that we've currently selected. And there's going to be a bunch of information and what it means about all the data in the packet. And at the bottom, we can actually see the raw packet data. So if we open up Wireshark again, look at that, look at one of these UDP packets that we have. So we see we have a list of all the packets that I captured on my computer, and then look down here, it's going to give us some details about what's in this packet. So we see some stuff going over Ethernet. Let's see, we're using IPv4, and then using UDP, and then there's some data that's being sent. So it'll show us a whole bunch of information here, and then we have just the raw data down here at the bottom. All right, so now we'll get into some of the protocols that we see there and what's actually going on. So first protocol we'll look at is TCP, the Transmission Control Protocol. And this is, if you remember the models we looked at, this is a transport layer protocol. And the important thing about TCP, it's going to provide a reliable transfer of data. So there are a few things it uses to do this. It'll establish a session, so we make sure we have a connection to the server, and we can check that everything's being received. It'll implement some error detection. The packets will be ordered, so we know which packets goes where in the data. And using TCP, we'll split the data up into IP packets to actually send it. And kind of a visual of how we're going to establish and end a connection in Wireshark. Okay. So yeah, when we want to establish a connection in Wireshark, we'll first send a SYN request to the server, and then it'll get that, send a SYN ACK back, then we send ACK to the server, and now we've established our connection for TCP, and then we want to end that. We just send our finished message, server acknowledges that, and then it's the same. We send our acknowledgement back, and when we're sending packets with TCP, we're going to see something kind of like this. We'll send it back to the server, and then it'll acknowledge that it got that and send a response back to us. And we'll wait a certain amount of time. If we get that response back, we're good. If we don't, then we can resend the packet, and that's kind of how we guarantee that it actually gets there. So the next one we'll look at is user datagram protocol. Like TCP, this is another transport layer protocol, but the difference is it's kind of like TCP's unreliable brother. There's no reliability. We just send packets and hope they get there. And you might be thinking, well, why would we want to do that? That's like, we have this way to ensure our communication is reliable. Why would we do this? Well, the answer is for something like streaming, like I'm doing right now. I don't have time to, well, you don't have time for, we can't wait to like get a request back or to retransmit a packet if we don't get a response that it was received properly. But by the time that I've waited 10 seconds for you to send a response back that you got a pixel on the screen and you didn't get it, well, now you're like 1,000 frames behind in the video. So yeah, and so we use UDP and we just send that data, and if you miss a couple pixels, it's probably going to be fine. So for something like streaming, you'd want to use UDP. And another concept with transport layer protocols is ports. So a port is a communication endpoint. So basically, an analogy you might hear for this is if the IP address, we'll see what that is shortly, like the IP address, you can think of that as like the address of an apartment building, and then the port would be like the actual apartment number in that building. So if you want to talk to someone there, you need to know the actual apartment number. Similar idea with a computer. Like you might have the address of the computer, but there are going to be a bunch of different applications or services running on that computer, and to specify which one you actually want to talk to, you specify the port. So ports are given a number between 0 and 65, 535, so we represent it with the 16-bit number. And there's going to be a set of ports for each transport protocol, so in other words, TCP and UDP. And yeah, there are some ports that are commonly assigned to certain services. For example, port 80 might be HTTP for seeing a web page, or you might SSH on port 22. And then a lot of the lower ones are assigned things like that, and higher ports might be not as well defined. Right, so we'll look at another protocol here, which is IP Internet Protocol. And if we go back to our model for networks. So the last couple protocols we looked at were transport layer protocols. This is kind of the layer down from that. So it's an internet or network layer protocol. And what it's going to do is, so yeah, how this works, it encapsulates data in something called datagrams, and it's going to decide how we're going to route that data between locations. And to determine routing, it is going to use the IP address of the destination computer. So we're just going to take a look at the chat quick here. Okay. The intercept modify request for Wireshark. It's not really, like you can see them, it's not the best for modifying stuff. There are other things like burp that would be better for that. Let's see. See a couple more here, but I don't think we're going to worry about those. So yeah, how IP is going to route data is it's going to use the IP address of the computer we want to send it to. So there are a couple different versions of IP addresses. So you'll see first is IPv4. So yeah, IPv4 address is going to look like this. You might have seen it. It's basically going to be 4 numbers between 0 and 256. And then second type of IP address, IPv6. This is becoming more common because, well, we ran out of IPv4 addresses basically. And that's going to look like some hex number separated by colons, something like this. Yeah, I won't go into too much detail about the exact formatting. Basically, there are more IPv6 addresses. That's the important part. And okay, so now we've seen a little bit of, seen a few protocols, so we'll look at Wireshark again. So often when you're using Wireshark, you'll see, yeah, you'll have a lot of data, and we want to filter the data because we're only interested in certain packets. So we can apply filters, and then we'll only see the data we're interested in. And there are a bunch of different filters we can use. For some examples, we have IP source or IP destination. We can specify we only want to look at packets that are coming from or going to a certain IP, or if we just type in a protocol, then it's only going to filter out packets that are using that protocol. We could specify only packets that are talking on a certain port, and we can apply multiple filters too if we just use the ampersand. And yeah, we'll just let's give an example of that. So let's say, like, if you want to filter out a certain protocol, let's search out HTTP, see that it reduces the number of packets there, or only see packets from, I don't know, a certain source. Let's say, what do we have here? Yeah, see, filter out the packets only coming from a certain place. So that's one way you can filter data. And another thing that's sort of related to this is streams. And with streams are going to be the data in a particular conversation. So we're going to capture a bunch of different network traffic. It might not all be related. But when we look at streams in Wireshark, it's going to look at the data as part of one particular interaction between maybe a client or a server. Yeah, so to that we can just look at analyze and follow streams in Wireshark, and it'll depend what we have selected. So as an example of that, yeah, I can follow UDP streams here. So this is going to give me bunch of data. And yeah, this is kind of hard to read. It's probably video data or something like that. So, and we can see that this will highlight client stuff that's being sent by the client in red, and then there'll be stuff being sent back by the server in blue. And yeah, you can kind of see the conversation going back and forth here. And you also see that it'll filter out only the packets in that conversation. I'm going to go look at the stream. Okay, so now I will finally give you a chance to test some of this out, and using some of the stuff you've seen about the protocol so far, and especially the filtering and streams that we just looked at. And you can try to find the flag in Wireshark 1. I will post the link to the files right away here. All right. So it looks like a few people have gotten the flag, so I think we'll just work through this quick for those of you that haven't gotten it yet. So let's open up the file, Wireshark. So we see we have some data here that is kind of funky looking because it is not actually real data, it's all made up. But so if you look at this, we have, see, it's all coming from the same place, but it's going to a few different IP addresses. So yeah, if you look through the data here, these first couple don't look very interesting. That one, we can see the start of the flag. And once again, if we see good stuff going to the same IP address, we see part of the flag here, but there's even easier way that we can use to look at this. We can just look at the streams in this file. So the first stream, not terribly helpful, but if we scroll through them, it's going to go through each of the streams, UDP streams in the file. And we see that the last one, well, the flag is being sent. So yeah, that's all there is to that one. All right, so yeah, now we'll go on to another networking protocol. Next, we're going to look at HTTP, or Hypertext Transfer Protocol. And if we think back to our model, the other ones we're looking at were a bit lower layer protocols. This is going to be a high layer protocol. And this is used for communication on the web. So it's going to be used a lot. Whenever you're going to a web page or something, you're probably using HTTP. So basic idea with this is client's going to send a request to a server for something, and then the server is going to send back a response. And that's the general idea of how it's going to work. We'll look a bit more at each of those. So first we'll look at requests. So this is sort of what an HTTP request is going to look like. So you see at the top here, we have a request line. We're going to have the URL we were sending a request to, and then that's just the version we're using. And then we're going to have a request method, and there are some different methods. These indicate what action we're going to be performing on that page. So for example, we have get here. Basically, that's just going to retrieve the resource that's at that page. Or another method we might have is post, and post is going to allow us to send parameters in the message body. So say we're filling out a form on a web page or something. So we'll use a post request. We can send the parameters with the data that we entered into the form. And there are a few more. I'm just going to mention one more here. The head request. This might be useful, like in some cases, if you're like trying to enumerate a web page and it's blocking GET requests or something. So basically, head's going to do the same thing as GET, except that server's not going to return a response payload. It's only going to return the headers in the response. So after a request line, we have some header fields in the request they're going to have some information. So you can see some examples here. For example, this is the length of what we're sending, or we have the user agent, basically the browser that we're using. And we're going to optionally have a message body that might be used for something like, say, post parameters, like we mentioned. And then after we send a request, we're going to get a response back from the server. So we're going to have a status code that indicates what happened because of a request. What was the result? And yeah, there are a few different ranges for responses. The first one is like, you see response, it's in the 100 range. Those are informational responses that may be used for, like, I think there's like switching protocols or continuing requests or something. I wouldn't worry about those too much. And 200, that indicates our request is successful. So normally if you request a web page and it sends it back to you without any problem, you're going to get a 200 OK response. So that indicates everything is fine, it worked out. A 300 response, that's going to be redirects. So for example, if a resource has been moved, maybe it's going to redirect you to another page, or if you've cached the web page on your computer, it's going to say, well, you can just use the version you have. So that might give you a 300 response. And then in the 400 range, it's going to be a client error. So you might have seen, for example, like a 404, which means the page isn't there. The resource you requested doesn't actually exist. So that would be one example of that. Or the last range we might have is in the 500s. That's going to indicate server error. So for example, I don't know, maybe something went wrong when, maybe the program crashed or something, or maybe you've seen like bad gateway or something like that. That would be a 500 response. So similar to requests, there are going to be some headers in the response that contain some different information. And once again, we can see some examples here. We have like the type of the content that was sent back, or the type of the server that's running. And then there's going to be a response payload, and that's quite often that's going to be the resource requested. So for example, if you requested a web page, it sends the page back. Then the HTML of that web page is going to be in the response. All right, so we'll use that in a little bit. Next, we're going to jump back to Wireshark, and we'll talk about exporting data. So we've seen a bunch of data that's just in a packet capture, but some of that data we can actually export to external files to work with it elsewhere. So for example, we can export the details about the packets we've captured as a text file, if you want to read it that way, or if there are encryption keys in here, we might be able to export those. Or if there's a website or a file that was transmitted, we might be able to export that. So just look at that quickly. So if you go under File, you see there's a bunch of options to export stuff. So you can export packets to different, we could choose certain packets to export, or we could export the packets as like text or a CSV. Or we could export like encryption key here, or objects. For example, if there's a web page or something, we could export HTTP object. You might want that later. So now using the HTTP stuff and that, we'll give you a few minutes to look at Wireshark 2 PCAP and see if you can find the flag in that data somewhere. All right. Looks like a good number of people have got the flags, so I think we'll go over this one. So let's follow up. So we see we have here, it looks like there's GET request to web server, and there's a response back here. So we can see the page that was sent back. It says, look at my drawing of a flag. And there's also an image on this page, which says flag.png. So that's interesting. And to run to the page, we're going to need to get the image too. So we see there's a request to get that picture. And it looks like that response has been sent back. We see we have a PNG here. So we can export this and actually look at it. So if we go to export objects under the file, we can see the HTTP stuff here. We see root, that's going to be the web page that we saw, and then there's the flag picture here. And we can just save that. And that's picture with flag. Yeah, so that's all we have to do for that challenge. All right, so I'll quickly go over one more protocol and then jump back into using Wireshark. So protocol we'll discuss next is TLS, or Transport Layer Security, and that's going to provide encryption of data. So when you're sending data over the internet, you might not want you might not want anything being seen by other people, probably not your bank password or something like that for sure. So we'll use TLS to encrypt data, and this is the S in HTTPS. So see, when you're talking to a website a lot of the time, you'll have HTTPS up in the top corner, and you'll have maybe a lock icon or something. Yeah, so the difference between this and what we saw before HTTP is HTTPS is HTTP encrypted using TLS. And that's basically what that means. So just basic idea of how TLS works. You'll create a session, the client and server will negotiate an encryption method, and then you'll use some public key cryptography to verify the server's identity, at least in theory. Should be, the server will have a certificate that's signed by an authority or whatever. I guess in theory, it should guarantee that the server is who you think it is, maybe. And yeah, then you'll generate an encryption key to actually use to encrypt the data you're sending back and forth. And well, if we look at this data in Wireshark, we're just going to see a bunch of gibberish because, well, it's encrypted, so we can't see it. But Wireshark includes some functionality to decrypt TLS data with a few conditions met. One, we need the key to decrypt it, and also it needs to capture the TLS handshake and be using RSA and a few other things. Basically, if you have the RSA key, we're going to be able to decrypt the TLS data. So how you do this, you can go to Edit, Preferences, Protocols, and then it'll be listed under SSL or TLS. That's going to depend on the version of Wireshark that you're using. And there you can add keys to decrypt data, and then once Wireshark decrypts that data, you'll be able to look in streams like we did before, or if you go to another tab in the bytes menu, you should be able to see the decrypted data as well. So I'll just show to navigate to that quickly. So if we go Edit Preferences, kind of Protocols, and then going to find SSL or TLS. It could be either one of those, depending on what version of Wireshark you have. In my version here, it's going to be SSL. And then we can edit our RSA key list here. And then you add a key. So you want to enter the IP address of the server and then the protocol to help with decrypting it. So probably HTTP. If it's web traffic going to a website, you want to enter here, and then you can find your key file. And then if the key has a password, you can enter it here. You won't have to worry about that. So yeah, now we have a challenge that deals with TLS, and you're going to want to use that to add a key and decrypt the data. So go with Wireshark 3.vcap, and you have the key in the Wireshark 3.key file. So I will give you a few more minutes to try to decrypt that and see if you can find the flag. All right. Looks like a few people have got this one, so go through it quick and move on. So first let's open up our file. So we have, looks like something encrypted with TLS. So we see client hello, server hello, sending your certificate back, and then key exchange. And we have some application data. So you see our handshake there to start the TLS encryption, and then we have the actual encrypted data. And all we have to do is add our key. So we'll go to Edit, Preferences, look for our protocol. And see the server we're talking to, well, there's only one IP address here, so we're just going to use that. And we're going to assume it's HTTP data, so we'll try entering that. And then we want to give it our key for decrypting that. So we have that key, and we see now it's decrypted this data as HTTP. And you see it shows us the decrypted data here. So there's a request, and then see here's the data before. You see it's decrypted, and then we can also see the actual file here. And that's going to contain our flag on that page. So all we're going to do there is just add our key, and then it'll decrypt it for us, and we can read it there. All right, so just one last protocol I'm going to mention here. That's domain name system. So basically, this is going to use to find the IP address from given a domain name. So basically, when you go to a web page, in most cases, you're not going to be entering the IP address. You're going to be entering some name that's easy to read and remember. For example, maybe you're going to go to google.com. So you type that into your browser, but then how does your computer know where to send it? Because you talked about IP earlier. We know it needs the IP address to determine where is it actually going to send that. So domain name system is going to be used to resolve that name to an IP address that the computer can actually use to access the page. So the basic idea of how this works is you're just going to make a request to a nearby DNS server saying, here, hey, I want to find this name, what's the IP address, and then if it's cached that IP address for that name, it'll send it back to you, or if not, it'll recursively call on another DNS server and work its way out until it finds it, sends it back to you. That's definitely a bit of an oversimplification of how it works, but I'm not going to worry about it too much. Basically, what you need to know is it's DNS is used to resolve the domain name that you want to visit to an IP address. And basically, you're just going to send a request and get a response back from the perspective of your computer. And I'll just mention one more feature about Wireshark as well. So another thing that Wireshark can do is give you statistics on the packets you capture. And there are a bunch of different statistics you can get. For example, it'll tell you like the number of packets that you have, or it'll give you details about the length of them, or it'll break all this data down by the different protocols. It'll give you IO graphs that describe basically what packets are being sent and received over time. And there's a pile of different statistics that you can see there. That's only a few of them. let's take a look at Wireshark again. So we see we have our statistics menu at the top here, and yeah, we can get some, this will just give us information about the file that packets are stored in, and see protocol hierarchy. This shows us all the packets and then broken down by protocols. So kind of working from the lower level protocols to the higher level ones we go in. So for example, if we look at our packets here, we see that, okay, we have like 90% of our packets are UDP, and most of that's data. That's probably because, again, I'm streaming, so that'll explain where most of that's coming from. And yeah, you can see some other things, like this will give details of the different conversations that are going on or different endpoints, basically applications or, well, the locations that we're talking between, and then you can get a graph showing the packets being sent and received over time. Yeah, you can see there's a whole pile of details here broken down by different protocols and stuff. So that's the last topic I'm going to cover today. And now, I know it's earlier in the semester, but it's time for the final exam. And yeah, I'm going to answer all these. You're going to look at Wireshark 4.pcap, and you want to answer each of these questions, and then you're going to be building the flag out of the answers to these questions, which I'm sure will not be annoying at all, but this is how we have this set up. So yeah, I'll give you a while to go through that and try to answer those questions. Okay. Let's go through the answers to these questions. Let's begin. Just open the file up here. Okay, so first question we have, what IPv4 address is associated with google.ca? So let's look at what we have in here. All we see, we have DNS queries and responses at the top here. So look at these. Well, one is going to be an IPv4 address. One is IPv6 if we look at the responses. And it asks for the v4 address, so that's included right here in the DNS response. Or we can also open it up down here. If you look at DNS, the answers, it'll show us that address. So that's our first question. And then there's a TCP conversation, packets 5 and 6. What is the checksum value? So if we look at packet 5 here, we can look at our packet details down here. If we look under TCP, we'll see that we have an entry for the checksum value. So this is 0xFE30. That's basically the checksum value for that packet, at least. So next question, what are the contents of the server header in the HTTP response? Well, if we look here, we only have 2 packets that are HTTP. You see the first one is a GET request of some sort. And if we look at this one, well, this is going to be our response back to that. So we can go down here to our details again. If we look under HTTP this time, and it wanted us to find the server header, which is listed right here along with the other header details. So we have Apache and running on Ubuntu. So that's going to be a server header, and if you're entering the flag having formatting issues or something, make sure you take out the space and don't include the new line on the end either. And then the last question we have is, what is the average length of all the packets according to the statistics? So we can just look at the statistics here, and we have a packet lengths option, so we probably want to look there. And if we look here, this is for all packets at the top, and we see that our average is going to be 160.36. So yeah, that's the answer to those. And that's our last challenge for this workshop today. And yeah, that's definitely not everything there is to know about Wireshark and networking. It's really just a basic introduction. If you want to mess around and explore some more, you can just capture some packets, poke around, see what you find, preferably on your own computer. Don't do it just anywhere. And I think there's some challenges in probably Pico CTF 2018 on this. They're probably going to look really familiar. A lot of the challenges today were based on those. So yeah, that's all for tonight. Good night, everyone.
I'm just going to jump in right here at the end to say thank you guys for sticking around and hope you enjoyed that. Next week, we have Emily Baird hosting our workshop on cross-site scripting. It's going to be a good one. Hope to see you there for that. We're going to have someone in our Discord server who's going to be streaming something soon. I think Ackman is going to be streaming either Hack the Box or Try Hack Me. He's going to be working on something if anyone wants to drop in and see what's going on there. Otherwise, we'll see you guys next week for another workshop, and hope you guys have a good week. Just to mention, we're going to be at Clubs Week this week. It's all online. It's just a Zoom call that you can join and say hi. If you want to come and say hi to some of us, feel free to drop in on that and introduce yourselves. We know you guys on Discord but sometimes not in real life. It's going to be really awkward when we all come back in person and have to exchange Discord handles instead of names and recognizing each other. But yeah, feel free to drop in and say hi, and we'll see you guys next week. Thanks everyone for sticking around. Hope you have a good night.
Just one quick note before we end the stream. Just a reminder that that the attendance form counts towards your membership. So if you want to be a voting member and you attended tonight's workshop and you're here, then you've got to make sure to sign the attendance sheet if you want it to count. That's all.
All right, there we go. Have a good week, everyone. We'll